Hello, statistics student. This video is for chapter 10.3, hypothesis test for two population proportions. We're comparing two population proportions using hypothesis test and confidence interval. So we did two examples, so this is the third one. In this example, we are comparing Hispanic students proportion in two community college. One is in Cabrillo College, and during a particular year, they find that there was 1,840 Hispanic students in this college out of 12,328 students. And then this is a very big college. And then at another Lake Tahoe College, there were 321 Hispanic students out of 2,441 students. So do we know that the proportion are the same? Let's just casually look at the sample, right? So we would say, because they talk about Cabrillo College first, so we say that's population 1. Now you would say, well, you already have the whole total students, so that is, why do you have to estimate? We're estimating it because it's from different years. So they just pick one year, randomly pick year. So over the years, so you would have different percentage of Hispanic students. So that's why it's still a sample. So 12,328, and there's 1840. So if I divide 1840 by 12328, I got 14.9%. And then for Lake Tahoe School College is 321 divided by 2441, right? So that's 13.2%. So obviously there's difference, but they're quite close, right? Can we say that, well, but the sample size is quite large. So can we say that they're the same? They're just, if they're the same, then we can say that we cannot say that one is higher than the other. So let's see what the claim is. The claim is the significant level is 1%. That percent of Hispanic students is higher in Cabrillo College. So they're thinking 14.9 is actually quite high. It is higher than that. Okay, so let's do the steps. So the first, I don't have any procedures here, so I would just do it free-handed. So first you have the data, and then what is the claim? The claim is Cabrillo, which is P1, right? So you would say claim is for P1 greater, like it's higher is P2. And then and then our X0 would be what? It's always the same. And then our alternative is would cover the claim P1 greater than P2. So this is where the claim is. You have to write it down. And remember, if it is like that, in your final conclusion, you can use the support statement. And then do we have alpha? Well, our alpha is actually 0.01. For ones, we usually use 0.05. And then this is a left tail or right tail test, or it's a right tail test. And so when we do the alternative hypothesis, we have to make sure that we do greater than, and we use z because it's proportion. Then the third step is to find the p-value and test statistics by using StatDis. So get StatDis over here. Oh, we changed it to 0.01. I didn't write it down, so let me write this down first. What? 12328, and then 1840. 2441 for N2. X2 is 321. Okay, so 12328. You can see that the sample size is very different. 1840. This one is a smaller college, so during that year they only have 2,000. That's really small. It's like a high school, right? 321. So number of success is 321 for that one. This is 14%, this is 13%. So do you think that they are different? Okay, so make sure that, oh no, is it bigger, right? So I always forgot this. So 1 is bigger than 2, so evaluate again. 1 is bigger than 2. It's a good idea to always check this. So the test statistics is 2.27, round to 2 places. P-value is 0.01169. Greater. We say this is greater than that. Okay. So right down, we use that this. Z is 2. What is it? 2.27. P-value is 0.01169. Okay, so but what is our usually if it is 0.05, if we see 0.01 something, we know that we have to reject X0. If it's a rare sample, it's 2.27 tick mark. So Cabrola College subtract Lake Tahoe College, the proportion is actually 2 tick mark away from 0. But the p-value is 0.1169. I just want to show you that even if you have a quite low p-value, if you set your significant level to 0.01, it is not less than. It's actually greater than 0.01, right? So it's not significant. It's not rare. It's very borderline. You should do it again. So it's almost greater than, but it's still within the um, guideline of the sampling variation. So the difference is is because of variation. You cannot say that they are different. Even if you have a same population, they could have a difference like that. 14.9 to 13.2 could be because of sampling variation. So it is so not significant. So we say what? Fail to reject 0. And if you fail to reject 0, so there is what? Not sufficient evidence. And we would not say reject, we would say support, right? Not sufficient evidence to, right? Because the claim is the XA to support the claim. We cannot support the claim that it is larger. Higher proportion of Hispanic students at Cabrola College. So they are very borderline, but still the same. Okay, so this is how we do it. If they didn't ask for confidence intervals, you don't have to, but we can look at the confidence interval. What did they say? Now this is a example, so you can see that it is 98% and it is all positive. So if you look at the confidence interval, you would say that P1 actually is greater than P2. Do you agree? Because they're positive. But how come the p-value say that it is not? These are the cases where it is borderline. So in this case, we look at the p-value answer instead of the confidence interval. They contradict, right? In very rare case, they do happen. Okay, and in this case, they didn't ask, so we just use the hypothesis testing procedure. The hypothesis test procedure is always more accurate. And then example 4 is the contrast. We would have a example where we want to compare proportion, but we would only use confidence interval. We do not actually do the hypothesis. So let's look at this example. In a random sample of 100 forests in the United States, 56 were coniferous or contain conifer. In the random sample of 80 forests in Mexico, 40 were coniferous. Is the proportion of conifer in the United States statistically more than those in Mexico? So we can actually calculate a little bit. We will say, okay, they talk about United States first. So population 1 is United States forest, and 1 is 100, and X1 is 56. So obviously that's 56%, right? Because 56 over 100. Mexico's forest, we pick 80. X2 is 40, so 40 over 80 is 50%. So it seems like America has 5% more. So that's what they want to claim, that the proportion of conifer forests in the United States statistically. The sample showed that more, but they are more, but it could be because of sample variation. So we want to see if it is statistically more. So your claim would be P1 greater than P2, and then our X0 is P1 equal to P2. Our hypothesis, alternative is P1 greater than P2 because the ratio test, because our claim would be in the alternative. Now, instead of doing the whole hypothesis test, we can actually do the confidence interval to determine. So to do the confidence interval, let's look at what is a significant level we have. We have 1%, and because it's a ratio test, so the appropriate C level is 98%. Okay, because you would have to think of, okay, so 1% is only on the right side because you're talking about greater than, right? But confidence interval is always the middle. So we would just pretend that there is another 1% here. So you have to subtract 100%. This is C level. C level is always in the middle. Alpha is here. This is 1%. This is another 1%. So making the middle to be 98%. So you can see, instead of doing hypothesis, I can do analysis confidence interval only. And I would say I'm doing proportion to samples. They look the same as what we're doing hypothesis, except they don't ask for significant level, they ask for the confidence level. So you have to actually personally calculate this for them. It's not 95%, it's not 99, but you have to look at the types of tests and everything. Okay, so you do the same sample size, which is what, 100, right? And then 56. That's for the America one. And then Mexico is 80 forests, and we have 40 conifer. And then we evaluate. They do have a p-value that they give you, but you're looking at the confidence interval. The confidence interval is negative 0.114 to positive 0.234. So I put my answer here. Negative 0.114, positive 0.234. What conclusion can we do? We could actually use that particular p-value, but we can just look at the answer here. The 0 is in the interval, right? So because you have negative 11%, positive 23%, so 0% is kind of here. So we say because 0 is in the interval, there is no significant difference. Although 56 and 50 seems to be big, they are because of sampling variation. But if we are to do the conclusion, what do we see? Because there is no difference, we say there is not sufficient evidence. They are not rare sample. And because our claim is in the alternative hypothesis, we say that not sufficient evidence to support the claim that United States has higher percentage of conifer. Okay, the difference is between negative 11, it could be lower, it could be higher, and it could be equal, and a 98% confidence. So that shows you how you can actually use the confidence interval to do a conclusion.